In this video, we are going to master the skill of factorizing expressions by removing common factors. By the end of this session, you will be able to identify and extract numerical, algebraic, and negative factors from both binomials and trinomials, just like you would see in an IGCSE exam. Here are our objectives. 1. Identify and extract common numerical factors. 2. Identify and extract common algebraic factors. 3. Factorize using a combination of both. 4. Handle negative factors and trinomials. Factorizing is simply the reverse of expanding brackets. Instead of multiplying a term into a bracket, we are looking for the highest common factor that divides into every term in the expression. Let's start with a simple numerical example. Our first goal is to extract common numerical factors. Let's look at a binomial expression. To factorize this, we look at the numbers 6 and 15 and ask, what is the largest number that divides into both? The factors of 6 are 1, 2, 3, and 6. And the factors of 15 are 1, 3, 5, and 15. The highest common factor is 3. We place the 3 outside of a set of brackets. To find what goes inside, we divide each term of the original expression by 3. 6x divided by 3 is 2x. And 15 divided by 3 is 5. So the result is 3 times the quantity, 2x plus 5. You can always check your answer by multiplying the 3 back into the bracket. 3 times 2x is 6x, and 3 times 5 is 15. It works. We have successfully met our first objective. Now, let's move to our second objective, identifying and extracting algebraic factors, where the commonality involves variables. Consider the expression x squared plus 7 times. If we write these terms out, we can see that both terms share a common factor of x. We pull the x to the outside of the bracket. Now we divide. X squared divided by x leaves us with just x, and 7 times divided by x leaves us with 7. So the factorized form is x bracket x plus 7. Notice that inside the bracket, the powers of the variables have decreased because we've moved one x to the outside. What if we have higher powers? Look at y cubed minus y squared. The highest common factor here is the lowest power present in both terms, which is y squared. When we take y squared out, y cubed divided by y squared is y, and y squared divided by itself is 1. Don't forget that 1, it acts as a placeholder to ensure that if we expanded the bracket, we'd get back to our original 2 terms. In many IGCSE questions, you will need to combine these skills. This brings us to our third objective, factorizing with a combination of numbers and variables. Let's look at 8a squared b plus 12ab. We need to find the highest common factor for the numbers and the variables separately. First, the numbers. The highest common factor of 8 and 12 is 4. Next, look at the variables. Both terms contain at least one a and at least one b, so the common algebraic factor is a b. This gives us a total common factor of 4ab. Now we divide the original terms by our common factor, 4ab. 8 divided by 4 is 2, and a squared b divided by ab leaves just 3. Putting it all together, we get 4ab bracket 2a plus 3. Take a second to look at that result. Inside the bracket, there are no more common factors between 2a and 3. This tells us we have factorized completely, which is a common instruction in exam papers. For our final objective, we will tackle trinomials and the specific case of removing a negative factor. Let's look at this trinomial, negative 5x squared plus 10x minus 20. In IGCSE exams, if the first term is negative, it is often cleaner to factorize out a negative number. Let's look for the highest common factor of 5, 10, and 20. That would be 5, but we are going to take out negative 5. When you divide by a negative number, all the signs inside the bracket will flip. Negative 5x squared divided by negative 5 gives us positive x squared. Positive 10x divided by negative 5 gives us negative 2x. And negative 20 divided by negative 5 gives us positive 4. The final factorized form is negative 5 bracket x squared minus 2x plus 4. Notice how the signs changed. If you multiply it back out, you get exactly what we started with. This is a very useful technique for simplifying complex algebraic expressions. We have now covered numerical factors, algebraic variables, combined factors, and handling negative signs in trinomials. You're ready to tackle these in your exams.